So we've talked about quantification and negation. Now we're going to talk about other complex quantifications, and in particular how quantifiers interact with conjunction and disjunction. So one piece of terminology that's going to be helpful in this discussion is the word scope. So what does it mean? So if we look at these two sentences, negation of P arrow Q on the one hand, and the conditional negation P arrow Q, each has two operators, a negation and a conditional, but they are related differently. So in the negation P arrow Q, the negation occurs higher in the tree than the conditional. The negation first shows up higher than the conditional first shows up. Whereas in the second one, the conditional shows up higher than the negation, at least when it first shows up. And so we say whichever one is higher in the tree has scope over the other one. It's above it in the tree. Okay, so just when we say it's one operator has scope over another operator, we're saying higher in the grammatical tree. That's what that means. Okay, so the way we're going to think about conjunction and disjunction and the quantifiers is by contrasting scopes. So let's look at two sentences with universals and conjunction. So the top one is a conjunction of two universals, for all x, lx, with for all x, nx. The bottom is for all x, and then there's a conjunction inside the quantifier, beneath the quantifier in the tree. The universal quantifier has scope over that conjunction in the bottom one. That's for all x, lx, and nx. So what do these two say? So the top one is a conjunction. It says everything is lonely and everything is a novelist. Okay. The bottom has just one, is a universal statement. So the top one, right, has two quantifiers in the symbolic language, so it's going to have two quantifiers in English when we move it back into English. The bottom one has only one quantifier in English, in the symbolic language, so it should also have only one quantifier in English. So it says everything is what? Both lonely and a novelist. So these two, they say the same thing. In the first one, the conjunction has scope. It's higher in the tree. It's above the two universal quantifiers. In the bottom one, the universal quantifier has scope. It's above the conjunction. And so they get different symbolizations. The first one has two, or English statements. The first one has two everythings, whereas the second one only has one. So same number of quantifiers in logic as number of quantifiers in English. Okay, but these two also say the same thing. Let's consider two different sentences. So here we're going to have existentials and conjunctions, and these ones are going to be different from each other. So the top one is a conjunction, and it has an existential on each side. So how would we, if we were going to write that out in English, you might pause the video and write that out, and then let's see what it says. So it's an and sentence. It's going to have two English quantifiers. So it's going to say something is lonely and something is a novelist. Maybe it's the same thing that's lonely and a novelist. That would then those sentences would be true, but maybe not. Maybe there's one lonely thing and there's one novelist, and they're different beings. The person that's lonely is not the person that's a novelist. Well, in that case, though, is something lonely? Yeah, the one. And is something a novelist? Yeah, the other. And so some x lx is true, some x nx is true, the conjunction is true. Let's look at the bottom sentence. Again, why don't you pause the video and symbolize or translate that into English? What do you think that means in English with the idea that there's only one some x in the logic, so there should be only one quantifier word in the English? The way we'd say this is something is both lonely and a novelist. Well, that requires that, in fact, there is one being that has both the properties of being lonely and a novelist. So that one says more. The bottom two say more than the top two. The bottom two say there's one thing that has both of the properties. And the way that sentence does that is by having an existential with a scope over a conjunction. Whereas the top one is a conjunction with two quantifiers. The conjunction has scope. Beneath the conjunction symbol are two existentials. And that conjunction just says they're both true. There's nothing about that sentence that forces it to be the same thing that is both lonely and a novelist. Is something lonely? This one. Is something a novelist? That one. So both pieces are true, so the conjunction is true. If you want to force it to, if you want to say it's the same thing, then you have to use the second sentence. So let's consider this scenario where we have one thing is lonely and one thing is a novelist. Then yeah, some x lx and some x nx is true, but is some x lx and nx true? No, none of those blue dots has both L and N. And so the conjunction LX and NX never comes out true. You take it to one thing, L comes out true, but N comes out false. You take it to another, N comes out true, but L comes out false. You take it to any of the others, both pieces are false. So there's no object there where you can take LX and NX and both pieces come out true. How would we fix it? The world. Well, we could put maybe L and N on the top right. And now they both of our sentences come out true. Is there something that's lonely? Yes. Something that's a novelist? Yes. So the top is true. But also we can find a particular thing that has both of them, and so the bottom one comes out true. Or it could be like this, right? Or it could be like that. What we need is to have, for the bottom to be true, at least one of them has both of them. And the top one doesn't require that. And so those two sentences say different things. So when those have different scope, when we have an existential and a conjunction, we're asking which has scope, then we get different sentences with different meanings. What about the existential and the disjunction? Some x lx or some x nx. That's equivalent to some x lx or nx. So the top one, something is lonely or something is a novelist. The bottom one, something is either lonely or a novelist. Okay, so the top one, the disjunction, has scope. The two quantifiers are beneath it. The bottom one, the quantifier, has scope, and the disjunction is beneath the quantifier. But although they have different grammar, these two turn out to always say the same thing. If there's something that's lonely, then both of them are true. If there's something that's a novelist, both of them are true. If there's something that's both, they're both true. But if nothing is lonely and nothing is a novelist, then they're both false. And you can verify that by just working through what happens when something is lonely. They both come out true. What happens when something is a novelist? They both come out true. What happens when something is both? They both come out true. When something is neither, they don't either come out true. Okay, what about some x lx or some x nx versus some x lx or nx? Top one, why don't you symbolize these two, and then I'll put them up or translate them. The first one, each thing is a lonely or each thing is a novelist. It's a disjunction. It's an or statement with two quantity phrases, each thing. The bottom one, each thing is either lonely or a novelist. So the top one is a disjunction. It has scope. The bottom one, the universal quantifier, has scope. They do not say the same thing. Why not? The bottom one doesn't tell us that either everything is a novelist or everything is lonely. It could be that some things are lonely and all the others are novelists. So, for example, let's look at this scenario. Suppose that, so in this scenario, is everything lonely? No. The center thing and the bottom right thing are not lonely. Is everything a novelist? No. The two things on the left are not novelists. So the top sentence is false, because is everything lonely? No. Is everything a novelist? No. So both pieces are false. So the or statement is false. So the top is false. What about the bottom sentence? That one is true. Why? The bottom sentence says each thing, the disjunction is true for that thing. So you look at the disjunction and you take it to each thing and ask, is it true? So we take the disjunction to the top left or the bottom left. It comes out true because the left side is true. If we take the disjunction to the middle or the bottom right, then the right side of the disjunction comes out true. NX comes out true. And if we take the disjunction to the top right, where it's L and N, then both pieces come out true. But for each of those things, we take LX or NX, the whole disjunction, to it, and each thing makes at least one piece of that disjunction true, and so that one comes out true. Okay? So is everything L? No. Is everything N? No. And so neither piece of the disjunction is true. But each thing is either L or N, and so that one comes out true. And so we can see that they are different. Sometimes they'll agree, but they don't agree in this scenario, and that makes them not equivalent. Okay, so when we're symbolizing, we want to make sure that each quantifier word in English gets its own quantifier in the logical language. So we should have the same number of quantifier words in English and quantifiers in logic. And then after we put in the quantifier in the logic, then we replace the quantifier word with the new variable, and we get an English logic mix. So I'm going to give some examples of how we do that in another video using the Logic 2010 symbolization module.